Hi everyone, welcome back to a new video. So in the last video we left at channels, so we'll continue from there. So this is the work we did in last videos. In the last video, I think I worked on this one, then we worked on this one. We have done this already. I'm just looking into these things so that I can get some idea where we left last time. We did a buffer channel and then we wanted to do more about buffer channel. Yes. We did not cover anything about ranging through a buffer channel. We did cover something about ranging through a unbuffered channel, right? So let's do that now. Let's say range buffered. I'll create a main file here. So what I'm going to do here is firstly, I'll create a channel. I'll pass values of int type into the channel. Let's say we are putting values 1, then we are putting 2, then we are putting 3. What I want to do is concurrently, I want to receive these values. So I'll create a Goroutine, a function that does what? That says for I and I'm going to range over the channel. So this is how we can range over an unbuffered channel, and this is how we range over a buffered channel. The only difference here is we are creating a closure. So we don't have to pass this channel here, right? We can directly access it from here. So I'll also do one more question after this where we will create an actual function rather than creating an anonymous function. First, let's do it this way. So we are going to range over this channel and we can simply print it. One thing you'll notice is here you'll not say this thing. Here you'll not be like this because here we have already taken each element from the channel. So will this work? We are putting 1 concurrently. This will be taken back. 2, it will be taken back. 3, it will be taken back. I think this should work. Let us check. Uh, Go run main.go. Taking some time. Yeah, it works. 1, 2, and then as soon as 3 was given, we know, see what happened here is as soon as 3 was given to the channel, now we are looking for, will this be, what do you call it? Will this be used? Is somebody listening to this? Yes, somebody is listening to this. But as soon as we would print that thing, it got over. The function main execution got over because if you see, channel's job is not to print stuff, right? Channel's job is if something is entering channel, there should be a listener. There is a listener, but by the time it would be printed, main function is gone, right? So it doesn't matter, right? If I do time dot sleep here, it will start working. Let me say 1 second. I think 1 second should be enough. See, now it prints. So you should know what's happening internally about channels. I've already talked about this in the previous videos. I hope you were able to understand and I hope you were able to foresee it, which I was not. So yes, this was the way through which we can range over a buffered channel. And we have already seen how we range over an unbuffered channel, which is quite similar, right? Range. Now let's do one more thing. Let's range over not an anonymous function, but an actual function. Let's say range 3. So what I'll do is I'll create another func. Let's say we are creating this print statement. It's called print statement. So now at this case, okay, we'll do this later on. We'll pass the arguments here later on. For now, let's move ahead. Let's come to main function. Let's create a channel here. Yes, ch, and I'll use int value, or I can use string here. Let's use string. And let's create a buffer channel. Let's say we want to have a lot of print statements, so that's 100, right? And now I'm passing in statements to it. So this is, yeah, 3 would be enough. Now, I think we can also combine a few things here. Either I can do weight groups, but we have already studied it. So let's see how we can use channels for synchronizing. I think we have done that already, but I want to show you creating two channels and then using it to synchronize. So let's create a channel called, let's call it weight. You can give it anything because it is just for synchronization. Now what we will do is we will pass this print statement as a go routine. And inside that print statement, we will create a weight. Like we will pass something into the weight channel. We have created weight here, but we will pass something to the weight channel inside this print statement. And we will simply say weight here. So I think this should be fine. Yeah. So what we are doing is we are creating weight here. Then we will pass, let me write it here only, differ. I want to do a function because differ only takes a function. So I'll have to say this thing here. I hope you are understanding why did I do this here rather than just saying weight and just putting a value called 1 inside the weight. Why did I do this? Because differ function requires you to create a function. Differ will only use a function. It cannot be a statement. So that's why we did this thing here. And it says weight is like waiting because we have not given weight here. We are not going to give weight here. Why? I hope you know closure. So we will give weight here. So let's say weight, which is a channel. So how we give this is chan weight int. I think this is how we give channels. Let me give one more channel ch and it is string. Yeah, this should work. Why is it not working? Oh, I think I did it this way. So it is ch. It is of type channel, right? Okay. Sorry, my bad. This is weight, and then we give the data type, right? For example, if this was I and int, so first we write this variable, then we give the data type, right? So similarly, what was it called? Weight, and it is a channel which takes in int. So now weight is fine. What we will do other than this is we will say ch we have created, we have given these values to ch. So we will simply range over ch and we will simply print stuff from ch. Once everything is print, we will say print statement func is completed. I should not say it here because it's inside the for loop. So we will say it here. FMT needs to be imported. We will import it. So now this looks quite good. We have to give two arguments. Let's do that. Ch and weight. Now everything looks good. So we will start from here. This executes. This creates the channel. One thing is put inside channel. Two thing is put inside channel. Third thing is put inside channel. We create another channel called weight. And we do this. After this, this will make sure this will become a blocking statement and make sure that weight has something inside it. That's why we are doing this. This will make sure weight has something inside it. So unless this runs, that basically means until this complete function is completed, because only after that differ would run. After differ is running and it has one value inside weight, only then weight will let the execution go after this. So now we can say end here. So I think this should work. Let's try deadlock. it goes to deadlock. Let's see where we are making mistake. Thankfully, we got this mistake because I did not remember to cover this concept, but now we can cover this concept. I think the issue is because, see, we created this channel and we are trying to range over the channel, right? How do we know this channel is completed? Yeah, so what we are doing is we have put some value, right? And now we are ranging over the channel and we keep on printing stuff. So this will keep on waiting for the channel, like if we will send more elements into the channel so that it can print it. That is the issue. I think before that, to be sure, I will solve it correctly. So what we have to do is we have given three channels here, like we have given three values to the channel here. So let's just say ch.close. Uh, this is not how we do it. So maybe it's close and then ch. What is it then? Is it small c? Yeah. So it is small c. This is how we close it. Now, if I try to run this, let's see if it works. It does work. So that was the issue. So now let me explain you what's happening. See, we have got a capacity of 100. We have placed three items into the channel. Now we are going here. This is running concurrently. And we are saying, okay, range over the channel. But how do we know that channel has no elements left? It will keep on ranging, right? If I do it 3 and then run it, removing the close statement, it still gives deadlock. Okay, so first, second, third, and it keeps on waiting. Yeah. So this is regardless of this 3 or 100. Okay, I thought this would be 3, so it will stop listening, but that's not how it works apparently. Yeah. So what's happening is, unless we close the channel, it keeps on waiting for the channel to be completed. Like for the channel to pass in, sorry for that, for the channel to pass more values so that we can range over them. So what will happen is this for loop will never exit. This for loop like will keep on looking for more values and more values, so it will cause deadlock. But now that we have added close, so this gets the channel gets closed, so it knows only three values are there. Three values will be printed. This will be printed, and we will call the differ function. Differ function will put something into the wait, so this blocking statement will then pass, and we can move to the ending part. So now if we run it, it runs perfectly fine. And now that we have added close to this, I think you will be asking that in this case, in this question, used close here. If we need to close this for the for loop to not cause deadlock, then you must be asking that here also we have a for loop and we did not get a deadlock. Why is it so? Right? I am also seeing this question. So rather we should be doing here this thing that we have added 100 to we have added 100 to the channel, and then we should be doing close ch, right? So closing the channel once the sender has done its work and sent all the values is important, and you should always do it. Otherwise, you may run into deadlocks. In our case, we did not do it because it's the main function. So if you look carefully, why did I not add close here? It will run iterate over 100 times and put 100 values inside the ch from 0 till 99. Then the main function itself ends. So if the main function itself ends, main execution is ending, right? So we will not cause any deadlock at this case because the main function itself is ending. So the execution ends, right? So the channels and all those things automatically gets closed. But if we do time dot sleep, I think if we make it sleep for a longer time, it may cause a deadlock. Let's say 20 seconds. If this will not cause, we will increase the seconds. CD reach. Okay, so we need to first remove this thing. It will take a lot of time. Okay, so it runs 100 times, goes here. This is range, right? Concurrency range. So this runs 100 times, it prints it 100 times. Why does it not sleep for 20 seconds? So we created a for loop, put 100 things inside it. Concurrently, this is taking values from range. There is no closure, like there is no close statement. What if I add time dot seconds? Let us try again. Just one chance. Yeah, now it works. Because I forgot that this is not a second. If I don't add seconds, this I think is microseconds. Default value. I don't remember exactly. Now it gets finished in 20 seconds and it does not give us any error. Okay. So it's not giving us any form of error because it knows after 20 seconds the main function will be executed. Only when we will create channels will it give us that case. Let us do one thing. Let us create another channel. Int. And I'll put stuff into it here. Once the ranging is done, I can use differ, but I don't want to use differ right now. So I'll simply say to and I'll put stuff into it. Right. And I'll just say this thing here. So two will become a blocking statement here. I think what's happening here is the Go compiler is realizing that, okay, I'll have to just sleep for 20 seconds and then it will work, right? It sleeps for 20 seconds, but still does not give us deadlock. What's wrong? Two is not defined because we created it here. Let me create it here. Two is defined, put two something inside two, and this is the blocking statement. So now I would like to assume it wouldn't work. If it does, uh, let me be sure first. It will range over these many characters and then it puts two value inside it. I think one more thing here is okay. Let's run it. It gives a deadlock. It puts 99 values. It puts value till 99. Okay, fine. And now it keeps on waiting and it puts one value to it then and we will wait for this to be completed. So if I add close, what happens? And now it works. Yeah. So this was the case. So where I assumed that it was the case that I can put 20 sleep seconds, like I can make it sleep for 20 seconds, and the Go compiler would think, okay, uh, we need to close the channel, otherwise it will keep on looking for more stuff to be put into the channel. That was not true. This was the case that if we have a lot of stuff to put inside the channel, right? We are putting one thing and then removing one thing, putting one thing, removing one thing. Then it starts waiting for two here. But since the channel is not closed, when we make it a blocking statement, it is like still waiting for the channel to send some things so that it can receive it back. So now we have understood this thing. I think I'll remove all this stuff from here, all the double channels that we have created. Unless we have one single channel, it will always work, I think. So we just need to remove second channel from here. But it's a good practice to always close our channel. Let's run this for the final time so that I am sure that this is correct. Yeah, so it works fine. Yes, so even my doubts, some of my doubts are clear now. This thing is also done. We closed the channel. I think this was also working. Let's go back. Let's go to range 3. Yeah, it is also working. We put in three things and then we make sure that we close the channels, which is a good practice. Now let's talk about having multiple channels and how we can use select statement to selectively pick stuff from, like to selectively decide if this case happens, then we'll do this. If this case happens, then we'll do this. So you'll understand it better when once I type it. So let's say select. What we will do is it is fairly straightforward. Now you have got the idea, right? So I'll paste it a little bit, create a channel, create another channel. Let's call it 2. Let's not call it int, let's call it string. Let us put something into the channel in this one. 1, 2, 3. Without any arguments. Another go routine, similar way. This was not ch, this has to be 2. 2. Put ABC into it. ABC. Now what I want to do is, I want to create something called a select statement. What will select do? So select will help us select, uh, I'll type it here. Select is used to choose cases where each go routine is used. What I mean by this is, I can say case, and I can say, for example, we are receiving a value from ch. If this happens, what this means is, if we are receiving value from the ch channel, then we can do whatever we want to do here, right? Whatever. Similarly, if we receive a value from, let's say, a only, if we receive a value from 2, then we can also do whatever we want to do. So this is what happens with select. I think you will be able to relate select to switch statement. Looks quite similar, right? So yes, it is quite similar. What does is, let us not say whatever. Let us print some stuff. Let us say from ch, and we will print a. And here we'll say from 2, and we will print a again. Yeah. So what this select statement does is, this through select statement, we can have multiple cases. And by case, what I mean is, if something is entering, like if something we are exiting from ch, then they should run. If something is being removed from 2, then they should run. Now tell me one thing. We have added something to ch. We have added something to 2 also. These things will make sure that, okay, we are listening to both of them. Now, if we put something into ch, and if we are saying, okay, something if is removed from ch, then this should be printed. What will this print? I hope you were able to get it. Only this statement will be printed because it is running only once. The select statement is running only once, right? We can create a for loop. After this, we'll do. But for now, only one is running. So we'll say, is A listening to ch? Yes, it is. So we'll print A. Then is A listening to 2? I mean, we'll not go to this case. So we'll simply exit the select statement. So we'll not look into this. Okay. So we'll go to select and we'll say, is A listening to ch? Yes, it is. Print that stuff. And this will be left and we will simply go out of it. So even though we are not printing anything from 2, still it will not give us a deadlock. Let us try. This is select, and we can see that from CHA, right? One interesting thing that I just talked about was we are not printing anything from 2. We are not receiving anything from 2. Still it does not give us an error, because like I said, channel's job is not to print anything or not to do anything with it. Channel's job is that if somebody is sending something to channel, there should be a listener, and there is a listener. What we do with that listen does not matter, right? Now let us do one more thing here. Let us create a for loop. I is equals to 0, I smaller than 2, I plus plus, and we'll put this stuff inside the for loop. Now what do you think happens? This for loop will run twice. So first select, okay, for in the first iteration, we'll reach select, we'll say, okay, is CH listening? Is A listening to CH? Yes, it is. Is A sending something? Yes, it is. Print this and exit. Another loop, this is already done. So it will not listen to, like it will say, is there anything left in CH? No, we have already removed. So CH is already empty. So remove this, reach here. Is there something in 2? Yes. Is we are listening? Are we listening to 2? Are we listening to 2? Yes, we are. Is there something in 2? Yes, there is. So it will print this one. So this time both should be printed. Let us try. And we see both of them are printed. And what we see here is that 2 prints first. So that would mean that this go routine ran first. As in this go routine placed this thing inside 2. So this one was empty. So it just went to 2 there. So this is basically how select statement works. And this is how all the channels and stuff works. So I think we have covered almost everything that was there with channels. We started with like unbuffered channel. We also talked about buffer channels. We saw how we can range over these channels. And we saw like, what is this? How we can use weight groups with channels. Then there is, this is a basic one. This is where we started, I think. We talked about buffer channels, and we talked about closing the channels as well. We also talked about select statements in channels. So I think almost all of that is completed now. I hope you were able to understand channels. Now let's move next to mutexes or mutex. So let's say mutex now. Why do we need mutex? You will see in this example. So let us say we have a number initially which is at 0, right? And then we will concurrently run, or we will concurrently increment it by 100 times. So what should be the answer? If we keep on adding 1 to A 100 times, it should be 100, right? And I think 100 would be correct also. So let's not do 100, let's do 1000. So if I add 1000 times to A, then it should be 1000, right? Let's see if that is the case. We'll create a for loop. Yeah, this will run 1000 times. And we will create a go routine here. And we will do A plus plus. And now we will print the value of A. Is it correct? We created A. We are looping 1000 times. 1000 go routines will be created, and we are going to do A plus plus. It is a closure, so it should work. And we are simply printing it. Let us see if it works. Mutex. Now, if you see the answer, this is not 1000, way less than that, right? Let me do 100. I think 100 should be correct. Even 100 is wrong. Let us do 10. Even 10 is wrong. That is surprising for me as well. Let me remove this thing here. Let me remove this thing here. Now we are just doing it 10 times without any go routines. Now you will see it is a correct answer. Even if I do 1000, it will be correct, right? What happens when we are doing it concurrently? Before that, one more thing I like to point out is if I run it again, this gives me 976. If I run it again, this gives me a different number. Every time it gives me a different number. When what we are doing is we are performing a basic calculation. Why is this happening? So let us see why is this happening. What's happening here is this is creating go routines. So all of the stuff will happen concurrently, right? Now that all the stuff is happening concurrently, for example, if I is at 1 and for example, at this case, A was 0. Okay. So if A was 0, now two go routines were created. One go routine, according to one go routine, A is 0. Since it is being created concurrently, according to another go routine, A is still 0. Right? So if both of them say A is 0, what will one do? One will increment A plus plus. So now A will become how much? 1. Here also one will do A plus plus. So now A will become how much? Still 1. That's why. That is the reason we are not reaching 1000 because sometimes this would happen and instead of adding 1 two times, it will only add 1 once. Right? So that is the issue with running stuff concurrently. It is called race condition. What do I mean by that? I mean that multiple Go routines are trying to access and modify this same data, right? So they are modifying the same data concurrently, but as we see, this type of issues can come because of which it will give us incorrect and inconsistent answers, right? That is the issue we have with concurrency, that we can have this race condition where two things, it's like two different things are trying to work on the same stuff because of which some discrepancies or like inconsistencies could happen. How can we fix this? So this is fixed via mutex. And this also is present in sync package. So what we can do here is, see, what's the issue? What do we want? We do not want two like two Go routines to do A plus plus together, right? So how we can do that is we can say mu dot lock. So we have applied a lock and we can now say mu dot unlock. What lock does is lock makes sure that only one Go routine is working on whatever there is inside this lock, whatever there is between lock and unlock. So only when one Go routine comes, it will acquire the lock. So now another Go routine will not enter it. It will wait. The second Go routine has to wait. Unless the first Go routine leaves the lock, only then the other Go routine can again acquire the lock and then it will do the same with the third Go routine. Now, one more issue I think will be there. That's why this was so drastic numbers, because I think this should be like one or two less, but these are really drastic numbers. I think that is because, see, we did create 1000 Go routines, but before adding stuff, this will end also. So this is ending really soon. There is nothing that will stop it to end. So we can also add a wait group here. That may also be an issue. So we add a wait group, sync. It's called sync dot wait group. And every time we create a new Go routine, we have to do add. It will add 1 And every time the go routine is completed, we'll do defer wg dot done. And here we'll say wg dot wait. Right. Now let's try running this. Okay, interesting. Still gives us wrong answer. Why is it an issue? Why have I created this here? This is so stupid of me. We should have created it here, right? Why am I creating this mutex inside the for loop? Now it should work fine. Yes, it does. Let me also try one more thing. What if we remove the wait group? I assume it will still give us an error. Think package is already being used. Not an error, actually. Wrong answer. Yeah. So it does give us wrong answer. Even when we have applied mutex, it gives us wrong answer. That is because it is running and then mutex is being followed. But like whenever some go routines are being created, but they are not even being executed. So the main function is exiting before those being executed. That's why we have used wait group here. And that's why these answers are so drastically different. Because if I had used a case where I was waiting for, okay, let's do it. No, let's do it also. Let's remove mutex. Let's add wait group. This is really good. This is such a good example. We can use like different combinations we are using. That is great. Let us do this now. So now we have added wait group. All of them are being executed. But this time, surprisingly, it gives us the right answer. We are not using mutex, right? Mutex. Yes, we are not. Let me increase the number then. 10,000. Yeah. Now we see some difference. That's what I was trying to tell you. That if these are small numbers, no, then it will still give us the right answer because there is less chance that we are creating two go routines which will create this race condition. Earlier, what was the issue? I hope you understood. Earlier, the issue was that go routines were being created, but the main execution was ending. So some go routine left without being completed. Let us do 1000. We have already done. So let us do it again. 1000. See, again, wrong. We did not change anything. We have not added mutex yet. But the difference is very less. If you see, the difference is only that of 17 here, 16 here. Earlier, it was much drastic difference. If I remove this also, let me remove this also. Now, if you see, drastic difference will be there. Let me do it again. Not a drastic difference. Again, not a drastic difference. Again. So somehow, I mean, this is like variable. So like I cannot control it. So not drastic difference at this case. Maybe I have a bad luck. See this. This is what I was talking about. This is like 300, more than 300 less. That's what I'm talking about. That sometimes it can cause drastic change. With wait group, this will never be the case. Let me only add wait group here. Wait group. Sync package and wait group. Now, whenever we run, this will give us some change, but not drastic. So this is very interesting. And this case, yeah. So I've run it so many times, it gives us the closer answer. And when we use both of them, it should give us the correct answer. I hope you were able to understand what's happening here. I'll explain this, I'll summarize this for the last time here. Now it should always give us the right answer. Yeah. So what's happening here is we have created this wait group so that all of these go routines are executed, are completed before we end the main function. And we have used mutex so that we can make sure that no two go routines are working on this condition at the same time. No two go routines are able to work at this condition at the same time. If one go routine has acquired the lock, other go routine will enter this condition only when this will not use the lock, or it will release the lock. Next, let's do one more, but I'll just come after a short break. The break is over and let's continue. We were at Mutex. We did this one. Now let's create another project where we will create a struct Mutex. So in this one, what we will do is we will create a video object and we will try to increment the views of that video. So let us create a struct called video. Yeah, it will have something called views, which will be of type int. Fine. Do we want to add something else here? I think it is good. Let us move ahead. So we will create v, which is a struct of type video, and the views are, let us say 100. We start with 100. Let us remove this. And we will run v dot. For that, we also have to create a method. So let us create a method which will take v video. Let us pass by reference so that if we are passing v here, then the same thing will be changed. Let us call it add views. I don't think I need anything else. And I'll simply say v dot views and I'll increment it by 1. And since we are passing a pointer, so we'll say address of operator we will add. And here we will say add views. We don't have to pass anything. No. And that's it. I just want to print the video, not video, v dot views. And we have to import fmt also. So let us see. I created a video which has 100 views. Video view, it is correct. Add views will run. So add views will run. It's a method. So yes, it's a method. It will increment the views by 1. Fine. And it should give us 101. Let us go back and say struct mutex and run this thing. So yes, it gives us, it was 100. It gives us 101. Perfectly fine. Let's do it. Not this. I'll run it 100 times. And 100 times I will add views. Now what do you think will be the answer? This was 100. 100 times we are running it. Firstly, tell me if this will give us an error or not. As in, like, it will give us some inconsistency or not. If you are saying no, then you are right, because it will give us 200. We are not doing any go routines and stuff as of now. Now let's do it. Let us say go routine here. Now it will create 100 go routines. Now also the thing is we need to create wait groups because we already know this will end simply, right? So let's do that thing, variable, or we can create it this way. Sync dot wait group. And as soon as we create a go routine, we'll say wg.add. Or I can tell you one more thing, one more way of doing this is wg.add, and I'll simply add 100 things because I already know this, like this is going to run 100 times. So we are adding 100, like 100 times, right? If we do wg.add and 1, this is same as this also, right? So I would rather, I can also use this one if I know how many go routines we are going to create. So this also works. And inside this, we need to add a differ function because we'll have to say wg.done. Now you will notice wg will not be understood by it because it is not an anonymous function. So closure would not work. So we'll have to pass in something called WG, which is a sync dot wait group. Here we will say WG. Oh, we are passing a pointer, so we have to say this address of. Now I think it should work. I created a object called video, 100 views it has. Wait group is created, added, and then this will run 100 times, 100 go routines. This will run, this will also run, and it will say done once it is done, and we'll move on. But we have not added wait, so I'll add wait. Yeah, now I think it should work. So now let's run it. It gives us 200. Will it give us 200 consistently? Maybe yes, because I have already said smaller numbers, go routines will work fine. Larger numbers, discrepancies will start coming. So I'll say views were 0 and 1000 views were added. Now let's see what's wrong. Oh, we have added 1000 here. Now 1000 go routines are created. We are only adding 100, right? That's why it is causing. So you have to be careful about this. That's why I would recommend always using wg.add1, because even if this was 1000, this would still have worked fine. So rather than this, we will open this one. Now you will see some inconsistencies. As soon as I said inconsistencies, now this is giving right answers. Yeah. So we are seeing some inconsistencies here. How do we fix this? We can fix this by the help of mutexes or mutex. We can create something called mu, and we can say it's a sync dot mutex. But I'll have to pass that mutex to this thing. So rather than adding mutex here, what we can do is we can simply add mutex here. Right? That would make more sense. And now that we have mutex already, it is a method of video. So we can simply say v.mu.log. And this should be not here, but here. We'll do lock and then v.mu.unlock. So we are going to lock it at the point where the views are being added. Makes sense? Yes, it does. Anything else we need to change? I don't think so. Because we have added mutex to be part of struct itself, so we don't have to change things here. That will save us some time. Fine, works fine. 1000 go routines. Every go routine will run perfectly. See, why we are using mutexes is that we want to make sure to take all the goodness of concurrency and not take all the badness of concurrency. So like if a lot of things were happening here, for example, then we need concurrency so that, like I told you already, we need concurrency so that we can effectively use our computer resources, so that we do not have to, like the core is not sitting, the CPU core is not sitting idle when something goes to IO, right? Something goes to IO, other things are still, like the core is still busy, but this thing will cause issue. So we will only add mutex to the point where it causes issue. So now this will not cause an issue. This will not create a race condition. And this was already fine. So we could take all the goodness of concurrency also. So this helped, the concurrency helped us here in dealing with these things. But here, where we did not have to deal with those things, where we did not need concurrency, here we will go one by one. That's the power of concurrency, and that's the power of mutex. Now let's run it. It gives us 1000, and it will always give us 1000. To be sure, let us say 10,000. If there would be any discrepancies or any inconsistencies, it will show it here. There is no inconsistency. That is how mutex works. So I hope you are able to understand what mutex are. Mutex is when multiple go routines are there and they are trying to access and modify the same value at the same time, which can cause inconsistencies. Through mutex, we can make sure that once a go routine acquires a lock, only when it releases the lock, can another go routine come and acquire the lock again. So at one time, only one go routine is working on this thing. Somehow the recording stopped. So I have to record this again. I think we were at what mutexes are and how they help. So mutexes, like I said, they give us the goodness of concurrency without dealing with the not so good part about concurrency, which is that it can cause race condition. So wherever there is possibility of race condition, we will use mutex, and wherever there is not, we will not use mutex because this will help us in making it better. For example, see, if there was a lot of code here and we did this. This will also work fine. But what is the point of concurrency then? What is the point of having Go routines? When you are only running one Go routine at a time, it doesn't make sense, right? It doesn't make sense to have Go routines when we are only running it at one at a time. That's why only where race condition is possible, only there we will add this lock and unlock, and the rest of the part should be left freely so that uh, Go routines can be run concurrently and our core or our CPU cores can be busy. And this will always give us 1000. Yeah. Now, one more thing I would like to talk about is this read write mutex, which is again mutex only, but with a slight twist. So for that, what we do is we'll say RW mutex. The idea behind read write mutex is that it will allow multiple Go routines to read at the race condition or wherever we are applying lock, but it will only allow one to write at a time. I hope you were able to understand that we can read it here, but we can only apply write, like only one Go routine can do write, but multiple Go routines can read. I think this would not work at this case because add views is like it is required to have a write lock here. So let us do one more method. Let us say get views. We'll do the same things here. Only difference is that we will, let us say, print the number of views. So we don't need this anymore. We can simply say v dot get views. It requires you to have a weight group. So let us add a weight group. Do we need a weight group? I don't think we would need a weight group. So we will just remove this. Let us try running it right now. Did I use RW mutex here? Yes. But here we are using mutex only. But for write mutex, it is lock and unlock only. So it should work fine. Yeah. Go run main.go. It works fine. Now this is printing our statement. I'm not sure if this is very logical, but let us do it anyways. Let us say v dot mutex dot. It is not present here. So dot r lock and v dot mu dot r unlock. So at this case, what happens is in this condition, multiple Go routines can do this thing, but they cannot write at this point. We are anyways not writing, so not a very accurate example. But I hope you were able to understand what read lock and write lock are. I think you can come up with a better example. Yeah, this is a very pathetic example for this. But yes, the idea behind this is that with RW mutex, RW mutex allows multiple Go routines to read, but only one can write at a time. And why would we do this? We would do this so that we can have more goodness of concurrency so that we can read stuff, which is great, but we can only write once at a time so that we can save ourselves from the race condition. So I think we have covered almost everything except a very good example of RW mutex. So I think you should be doing one really good example of RW mutex to make it clear. But I think I explained the theory part. Why did I remove this? This is why did I remove this? Yeah. So I think I explained the theory part really well for RW mutex. You have to look for a good example. You can do a good example and you will be able to figure out what RW mutex is. But I hope you were able to understand all the things I talked about in this video as well as the previous videos. I think this was the last video on Go concurrency. So in the entire series, we talked about weight groups, we talked about Go routines, how concurrency, like we started with what is concurrency, how it is different from parallelism. We talked about weight groups, about Go routines, channels, how channels are used for not only communication but also synchronization. We looked into how we can range over channels and buffered, unbuffered channels, then select statements, anonymous functions, a lot of things, right? Mutex, read write mutex. So I hope you were able to understand all these topics. I hope you also did all these programs because the idea behind doing these many programs, we could have done one program for each topic, but that would have not given you really good understanding. So I hope you did all the programs. That is very important for understanding. If you want to watch more videos on Go and on Kubernetes, then you can check out the channel. There are more videos on Go and Kubernetes. In either case, thank you for watching this one, and I'll see you in the next one.